A very good day to judges and audience. My name is Foo Wei from the Departments of Electrical, Electronic and System Engineering of the National University of Malaysia. And today I'm going to present my final year project entitled Control Nanostructured Material Thin Film Deposition with Automated Spraying Technique. In the first part, I'm going to say a few words about the research background. Thin film has been widely and commonly applied in electrical technology application that benefit in providing different properties over the material surface brought in bulks, make it favorable to be used for transistors, sensors, actuator, photovoltaic cell, touch panel, or even wearable smart devices. Advancement in electronic technology, non-structured material is being used to fulfill the need of high resolution, sensitivity, and high precision. Let's turn to next issue, which is the current challenge in nanostructured thin film. First is mass production. Large scale of thin film deposition at low cost is difficult to be achieved. Second challenge is selective production, difficult to control over the structure and properties of the thin film. And third is quality issue of thin film, which rely on deposition technique. Improper technique will cause degradation of the thin film performance. There are few common thin film deposition techniques used in research work such as vacuum filtration, spin coating, chemical vapor deposition, and spraying deposition. Spraying deposition is the best among those aforementioned for 1D materials such as nanorods, nanotubes, nanofiber, and nanowires. The reason is because this method is relatively cheap, simple compared to other methods. It can spray over large area of substrate and provide better uniformity and scalability. However, problem arises when using manual spraying. Human error will lead to low reproducibility and inconsistency in film properties. So these are the three problem statements for my final year project. First is the current airbrush system have design flow in terms of the physical hardware, circuit connection, and software programs that cause intermediate failure. And second one is the desired properties of carbon nanotube thin film, including surface uniformity and electrical properties, are difficult to be controlled and refabricated by using an artistic airbrush manually. And third one is the lack of system reference standard that can scale the electrical properties of carbon nanotube thin film, which corresponding to the reference to optimum spray parameters. Next, these are three objectives correspond to problem segments. The first one is to develop an automated airbrush system with improved hardware and software design for better system functionality. And second one is to investigate the optimum spray parameters to produce uniform thin film and achieve high reproducibility as well as solve the uncertainty problem in the automated airbrush system. And third one is to establish a correlation between the parameters of the automated airbrush system and the electrical properties of the thin film. So, for this scope of project, the deposition material is limited to single wall carbon nanotube, and definitely the deposition technique used is spray deposition, and the spraying tools that being used to develop the automated spraying machine is the commercially available artistic airbrush, while the thin film properties that going to be evaluated is its thickness and in uniformity, and the thin film electrical performance that used to be studied is the IV characteristic, and the sheet resistance and conductivity will be extracted as well. And these are the spraying parameters they are going to be studied in the following experiment. The reason of carbon nanotube being chosen in this project is because it has a very outstanding electrical properties, which has a very high current density, which is 1,000 times greater than copper or even aluminum. And in addition, it's a very good thermal conductivity, which is much more greater than copper's. And it has a very good mechanical flexibility and has a young modulus that close to 1 terapascal and has a very good optical transmittancy. This is a summary of literature review that has been done, and throughout the study, we realized that the spread deposition is being selected as the main investigated deposition method because of its outstanding advantages as listed at here. So this is an overview of methodology, includes phase 1 system verification and development, phase 2 experimentation in optimizing system parameter, phase 3 instrumentation for thin film characterization, and phase 4 data collection and correlation study. So the detail of flowchart of methodology, the left-hand side is the pathway that approaching first objective, while the experimental and characterization part is the way to approach my second and third objective as shown as this slide. PCC routing design is developed through the EDF tools, while the 3D printer part or automated spraying machine is designed by using on-chip modeling software. The software is developed through Arduino platform since the main controller used is Arduino Mega 2560. So these are the methodology for the instrumentation for thin film characterization. Basically, FM is used to obtain the thickness of thin film and observe the uniformity of thin film, and the digital microscope is used to observe the material surface structure. While the Gamry instrument is used to establish the IV relation across the thin film and also to obtain the sheet resistance and also conductivity. So these are the key spraying parameters to be studied, which include the spray duration and the number of passes through control the air valve and also the critical angle through control the mixture valve. And now I would like to move on to the result part. In terms of hardware development, the final schematic design has been drawn after proper validation on circuit connection and functionality. Transform to PCB routing design for actual board fabrication. PCB provide clean and tight connection, and the mounted socket ease the hardware problem troubleshooting in the future. This is the mechanical design of the control box, which allow user to control over the airbrush handler. It consists of the box cover in protecting the system circuitry, battery holder, and a support layer for user interface components. This is the actual 3D printed part control box that assembly it with the electronic components. It consists of the rotary encoder to allow user to select and access different menu and submenus that displays on the LCD screen. The spray tactile switch can be used to control the spray action, while the reset button allows user to reboot the machine. For airbrush handler, the rack is designed to hold the artistic airbrush, while the shaft controller, turning ring, a timing belt, and servo motor establish a pulley system that control the mixture valve. Besides, there's a simple gear mechanism that control the air pressure valve. In terms of the programming script development, it allows users to customize the range of the spray duration, time gap, number of passes option in different modes through the key system setting panels at the top of the Arduino script without accessing through the single line of the whole script. So basically, this developed system able to operate in 4 different modes. Mode 1 enable user to conduct spraying manually with either half or full opening of the mixture control valve. The duration of mixture flow at either only single spray or few number of sprays or passes can be controlled in a mode 2 and mode 3 respectively. And mode 4 is similar to mode 3, but it allows time delay setting between 2 successive sprays. And the picture here is just to demonstrate how the airbrush handler operates under different modes. And now I'm going to discuss the result of experiment part. This experiment is to investigate the optimum trigger angle of spray machine. As I mentioned earlier, although the thin film show better IV relation as trigger angle increases, but the droplet size being sprayed out is also increases as shown as here, labeled in a blue circle. Due to the nature of CNT solution with high surface tension, tiny droplets on the glass slide will tend to flow and form larger droplets, as observed in the microscope image. Thus, it introduced non-uniformity. Therefore, although the IV relation for 73 angles is relatively weak, but is being peaked as the optimum trigger angle because it produces relatively uniform thin film. And this is an FM image of one of the samples that has been sent to the laboratory, and this sample is fabricated with 3 passes and 0.5 spray duration. The average thickness is 324 nanometers, thus the calculated resistivity is 0.82 kilo ohm meters, and conductivity is 1.219 millisiemens per meter. This is the surface topology of the samples. So basically, there are 2 commonly used parameters to evaluate the surface roughness through the topologies. One is the arithmetical mean height, which is 0.0192 micrometers, and another one is root mean square of the surface roughness, which is 0.0242 micrometer for these particular samples. And there are 2 additional parameters we use to study the topology. One is the skewness, which is 0.237, which is very close to 0. That indicates that the mean height distribution is symmetrical around the mean plane. And regarding its kurtosis, which is 3.2275, which is very close to 3, which indicates that the high distribution is very close to normal distribution. That means that the surface roughness actually is smooth and um, rather more uniform. And this is an overview of automated airbrush system for the correlation study between the spray parameters and the different performance. So basically, there are a few parameters being fixed for the following experiment. First is the air pressure is being fixed to 15 psi, while the nozzle to substrate distance is fixed to 10 cm, and also the surface temperature for substrate is fixed to 80 degrees Celsius, and this trigger angle, as mentioned earlier, the optimum one is 73. So these parameters is being set due to the self-experiment and also by referring to the previous research. So this combination would provide relatively more uniform thin film. So they are being chosen for the following experiment. Experiment 1 is about correlation study between spray parameters and the resistance of thin film. These are three experiments that take spray duration as constant variable while number of buzzes as manipulated variable. Under same spray duration, as the number of buzzes increases, the resistance of thin film increases as well, as you can see in these three columns. Similarly, from another perspective, by looking at the same number of buzzes, the resistance of the thin film decreases and the pulse duration increases, as you can see at the same row here. So these are the two correlations that are being established. When observed through the digital microscope, the black dot become more and more concentrated as the spray duration or the number of buzzes increases. The black dot actually indicates the carbonarity while the white dot represents the surfactants of the CNT solution. This validates the correlation that has been established earlier. In terms of reproducibility test, the CNT thin film is reproduced 5 times under same spray parameters, and the test is repeated by using another 2 types of CNT solution as written here. The result shows that the maximum percentage difference of resulting resistance from its mean value is not more than 25. So the reproducibility for this such sensitive material is very high. And these are the future work can be carried out to accomplish this project. First, the thin film can be sent for laboratory to analyze the morphology through the PSAM characterization, and the thin film actually can conduct UV-vis measurement to evaluate their transmittance to see their absorbance. So they can use as the interactive panel application. And in conclusion, the objective one is achieved since that a workable automated airbrush system has been successfully built up, which actually provide different operation mode, and we emphasize on the high scalability so that this automated spraying machine is not only applicable on carbon nanotube but is applicable on the other nanostructured material as well. And objective 2 and objective 3 are achieved since that we have actually optimized a certain spray parameters for the relatively uniform thin film to be reproduced, and also we establish a relation between spray parameters and resistance of the thin film. These are the reference for my final year project, and we have reached to the end of the presentation. Thank you for listening. Thank you.